we're going to be doing looking at units of measurement. And there's two different systems. There's the U.S. standard system of measurement, and we're going to look at all these different units, like units of lengths that we use, inches, feet, yards, miles, and there's lots of conversions here. And I won't ask you to memorize any of these conversions. You'll have this chart, but you will be converting from one unit to the next. The volume, your cooking and so on, you've got these units of measurement, and you've got units of weight in the English standard system, units of time, and there's also a temperature. We use Fahrenheit generally, but there's also Celsius. The metric system, as you know, is based on base 10. And so to go from one unit to the next, you either multiply or divide by 10. And even the Celsius has something to do with base 10 as well, as you will see. So what we're going to be doing in this section is we're going to be primarily, we'll be adding, subtracting, and multiplying a couple units, but for the most part, we're going to be converting from one unit to the next. And we're going to do that, we're going to use this thing called dimensional analysis or unit analysis. And it's all based on multiplying by unit fractions. A unit fraction is a fraction that is equivalent to 1. And so when you see this first fraction here, like 12 on top and 1 over on the bottom, you might think, oh, that's equal to 12. But the unit is different. And so if you take something that's 12 inches long and divide it by something that's 1 foot long, since the length of 12 inches is the same as the length of 1 foot, you're taking something and dividing it by something that's equal to it. And a number divided by the same number, 5 divided by 5, 12 divided by 12, and so on, is equal to 1. But because the units are the different here, these unit of lengths here are exactly the same. So this is equal to 1, this one's equal to 1, 3 feet and 1 yard are the same, so this is equal to 1, and even this fraction over here is equal to 1, because the length on the top is equal to the length on the bottom. Now we're going to be using these fractions, these unit fractions, to convert from one unit to the next. We'll show you how to do that. So we're going to start right off doing the unit analysis problem, and then we'll get into the metric system. So we're going to start working with length of something. So we're going to be working with these primarily, and then we'll go to the metric system and work with lengths, convert from centimeters to millimeters and so on. And then we'll go up to area, and then we'll go to volume, and then we'll go to capacity, and then maybe some of these other ones as well. You can do this unit analysis in all of these different things that we like to measure. Now, if I said something like 2 feet is how many inches, you might be able to shoot back a number very quickly. How many inches are in 2 feet? Some things you just have experiences with. You can answer that. Okay, good. Thank you for answering. 2,640 feet is how many miles? Now that one you might not have as much experience with. You might not even know that there's 5,280 feet in 1 mile. So there are some things that you can convert, some of the simpler ones, but for the more complicated ones, like the one I just gave you, unit analysis might be the way to go. Okay, let's take a look. How about number 4? 100 feet is equal to how many inches? 100 feet is how many inches? Now here's how we're going to use the unit analysis here. We start with feet. We want to convert to inches. So we want to find a fraction, a unit fraction that involves feet and inches. And we're going to multiply 100 by one of those fractions, a unit fractions, because 100 feet times 1 is equal to 100 feet. But the one we're going to use here is one of those unit fractions. And we're going to choose the one that has feet in the bottom. So 1 foot is equal to 12 inches. So the fraction we're using is actually this one right here. Now what this enables us to do is to, and Tasha mentioned something about cross-canceling, but if by that she means we're going to cancel a unit on the top with a unit on the bottom, that's exactly what we're going to do here. And if you'll notice, if the feet unit has been canceled, the only unit remaining in this problem is inches. So our answer is going to be in inches. On top, we take 100 times 12, and that's 1200. And on the bottom, we have just the 1. And so 1200 over 1 is 1200. And so the answer to this one is that 100 feet is equal to 1200 inches, 1200 inches. Number 16, we have 0.25 miles. MI is the abbreviation for miles. That's a quarter of a mile. And they want to know how many feet are in a quarter of a mile. So it would be nice to find a unit fraction that's equal, that shows a relationship between miles and feet. And here we have 2 of them. So the question is, both of these are equal to 1. Both of these are unit fractions, as they call them. But we want to choose only one of them. We want to choose the one that works. So what if I chose the wrong one and I did this? And I said 1 mile is equal to 5,280 feet. Now this one wouldn't give us what we want, because notice that the mile unit is on the top in both places. So I can't cancel it. And since I can't cancel the unit, leaving me with feet, then I know that this is the inappropriate unit to use. So what I'm going to use instead is I'm going to flip those two, and I'm going to put the 5,280 feet on the top and the 1 mile on the bottom. Now I have the mile on the top that I can cancel with a mile on the bottom. And the unit we're after, feet, is in the numerator. So the only unit that didn't get canceled is feet, and that's going to be the unit that remains in our answer. So then all you have to do to get the rest of it is to get your calculator out and multiply 0.25 times 5,280. And so we get as the final answer 1320, and the only unit remaining is feet. 21 yards, and there are in one yard there are 36 inches. Yards cancel. So 21 times 36. Very good. This formula sheet, it pretty much is going to be all that you need to do all the conversions or any of the conversions that we're after. And there's 2 pages of it. And I put this, and you can have access to this when we do tests. And I put this formula sheet, it's 2 pages. This is what the first page looks like. Got the metric system as well as the units of length, area, volume. See temperature here. There are even conversions to convert back and forth between the metric system and the standard English standard system. All right, the metric system. And we have, it's based on, of course, base 10, and that's the advantage of it, because it's to convert from one unit to one lesser unit, you just either multiply or divide. And here are the symbols that we use. Millimeter, this is about the thickness of a dime, very, very small, thickness of a dime. A centimeter is about the length, the thickness of one of your fingers. Thickness of the pen, that's a centimeter. A decimeter would be 10 of those. So maybe the length of the pen would be a decimeter, maybe a little smaller. And then if you take 10 of those, you have a meter. And a meter is about the same length as a yard. A meter is 39-ish inches, a yard is 36-ish inches. If you take 10 of those meters, you get a decameter. And so that would be maybe the length across a big classroom. If you have 10 of those decameters, that equals 1 hectometer. And if you have 10 hectometers, then you have 1 kilometer or kilometer. And they give you all of these in reference to the base unit, which is a meter. As you take the smaller units, you divide by 10. 1/10 of a meter, 1/100th of a meter, 1,000th of a meter. Going the other way, 10 meters, 100 meters, 1,000 meters. And just so you know, those are not the only units we have, but those are just the most common ones. Here's some others. Here's where we left off. Decameter, these are the large ones. And we're now getting into some larger numbers because we're talking about bytes of information in a computer. And so we have decameter, Hectometer, kilometer. How big is your document? 75K, 75 kilobytes. And so now we have mega, so megabytes. I suppose if we had megameters, that would be 1,000,000 meters. And after megabytes comes gigabytes, and now we have phones and so on that store memory that have this size, gigabytes. And even some of the biggest hard drives now are terabytes. But they each go up by another 3 zeros. So millions, billions, trillions, and then after that, just use the prefixes that you've learned: quadrillion, quintillion, sextillion, septillion. If you went further, octillion, nonillion, and so on. But power of 10, you can see they go up by 3. Peta is a prefix that we use for quadrillion, and exa and zeta and yada. Some of these you probably have never heard about, but they just get bigger and bigger and bigger. And in the micro level, in the smaller level, we have deci, centi, millimeter, and that's where we stopped last time, but it even gets smaller than that. Micrometer, nanometer, picometer, femtometer, attometer. Viruses are that size, attometer, zepto and zacto. So we won't use many of these, but just to show you that, you know, there are some units of measurement that are bigger than the standard ones that we use. Okay. Why don't you go ahead and write down for each one of these in 57 to 66 how you would measure them. Would you measure them in millimeters, thickness of a dime, or meters, or kilometers? All right, so these are multiple choice. Write one of these next to each one of these here. So for example, a person's height, well, millimeters, it would be pretty large. And if you're in a foreign country and they use the metric system, when you ask how tall someone is, they'll say 1.5. I'm 1.5 tall. 1.7. Oh, you're 1.8? That's tall. And it's kind of an intuitive for them. So they measure a person's height in meters. Someone's height would be much too. All right. Over on this side, circle the correct answer, A, B, or C. The length of a pen. There's a pen. I think I might have a ruler here somewhere. So you have inches on this side, and most rulers come this day with both units. So about 5.5. And then these measurements here from 3 to 4, those are centimeters. So you can see here, because we're measuring it, this would be about 14 centimeters here. Back off, depends on how you, 13.5 maybe. So probably the answer that's best suited here, length of a pen, 30 centimeters would be even longer than the width of this page right here. So that's not a pen. Millimeters, 19 millimeters would be about from here to here. And that's certainly not the length of a pen. So probably the best unit would be this one. So you're estimating the length of these common things that you see, and you have to select the appropriate one. All right, go ahead, take a minute to do all these problems, just to give you a sense of the relative size of these units. And I think I'm going to go upload those documents for you that I forgot to do. Okay, I did load those documents up there. So if you wanted to go get the formula sheet, it's now up there. I'll put better titles on them here in a second. But, okay, so just quickly check your work. Length of a football field. Kilometers is probably too large. Probably like we say a football field's 100 yards long. We'd probably just say it's close to 100 meters long as well. Length of a bee, probably in millimeters. Distance from New York to DC, kilometers. Distance around an acre lot. Well, I'm going probably meters or kilometers, 1 acre lot, meters. Maybe a home out in the country, the lots might be a meter or an acre big. And so if you walked around it, you could probably walk around an acre and you'd only have a fraction of a kilometer. Length of a car in meters, width of a book. Books are relatively small, So it would be a fraction of a meter or millimeters. Altitude of an airplane, probably kilometers. They're up there a long way, probably about 5 miles for the longer flights. The diameter of a screw, millimeters definitely. The width of a human foot, probably the best measurement there would be millimeters as well. So the very, very small things that you're measuring, use millimeters. The very, very large things that you're measuring, kilometers, kilometers, and kind of those in between would be a meter. Length of this page, 250, that's about 25 centimeters. Height of a skyscraper, probably in meters, but not this far. Oh, it's in kilometers. Oh, there's one in meters. Yeah, these others are just too large. Probably 325 meters. Length of a pair of pants, probably 700 centimeters. Well, 700, that's about, no, that would be like 7 meters. I'm going to go with 70. That's a long pair of pants there, 700 centimeters. Height of a room, we know it's about 8 feet. And 8 feet would be most closely represented with, well, a decimeter would be, your hand is about the width of a decimeter. So 1, 2, 3, 4. No, that's not the height of the room. 4 meters is probably, it's a tall room. And the length of a rowboat, too small, probably 4 meters. All right, now we can do unit analysis when we convert within the metric system. But here's a little graphic that'll help you to do the conversion. It says, if you arrange them in this way, kilometers, hectometers, so that as you go from one to the next, you're multiplying by 10 or dividing by 10. So you arrange them from smallest metric unit to largest, the largest on the left. Then if you're converting from one of these units to another one, every time you make a jump, you multiply by 10. So if you have to make 2 jumps, you're multiplying by 100. If you have 3 jumps, you got to multiply by 1,000, and so on. On the other hand, if you're going from millimeters to meters, you would want to go 3 places to the 3 units to the left. And every time you go 1 unit to the left, you're going to be dividing by 10 as opposed to multiplying by 10. So let's take a look at this. And this happens not only with lengths, but it happens with capacities and masses, weights, and various other things. So let me show you how this works. And I'll do a couple of problems, beginnings on the next page. We're going to convert 8 decameters to meters. So here is decameters, and we want to convert to meters. That's just 1 jump to the right. And when we jump to the right, we're going to multiply by 10 one time. So we're going to multiply by 10. 8. Here's a decimal point. Multiplying by 10 just requires us to move the decimal point 1 place to the right. All right, so hectometers. This is number 18. Yeah, I mean, there's the answer. I didn't say it, but that's it. The unit analysis would be this. We'd take 8 DAM, and then we would multiply 1 DAM is equal to 10M. The DAMs would cancel. 8 times 10 is 80, and we'd have 80 meters. So we can still do the unit analysis work to get 80 meters, but what that graphic said is all we have to do is to move the decimal point. When we multiply by 10, we move the decimal point to the right. When we divide by 10, we move the decimal point to the left. 22. 8.64 HM is equal to how many CMs? So memorize these units: kilometers, hectometer, decameter, then meter, decimeter, centimeter, and millimeter. So we're starting with hectometer right here, and we're moving to centimeter, which is down here. So we move 1, 2, 3, and 4. 4 places to the right. So take the 8.64, tack on a bunch of zeros, and then we're going to move 1, 2, 3, 4. 1, 2, 3, and we're going to end up right there. So that number is 86400, or 86,400 centimeters. I don't memorize myself personally. I mean, I know the relationship between these units and how far they are from one to the next. Like, for example, I know that 1, 2, 3, 4, the relationship here is 10,000 to 1. 10,000 of the smaller units equal 1 of the larger units. But instead, what I do is I say, okay, HM is the larger unit compared to CM. So if HM is the larger unit, then the larger number between this one and this one has to go with the centimeters. So if I have a question about whether I'm moving from to the left of that 4 places to the left or 4 places to the right, I'm definitely going to move it to the right because I know this number here, since it has a smaller unit, it has to have a larger number in front of that unit for these two to be equal. 24, I'll do one more and then I'll ask you to do one. 0.00037 kilometers is equal to how many centimeters? So we're going from kilometers to centimeters. 1, 2, 3, 4, 5. 5 places. So we're going to move our decimal point 5 places to the right. We'll start with the decimal point where it is and go 1, 2, 3, 4, 5. And that's where it ends up. So we don't need these extra zeros on the beginning and on the end, so we just get 37. So this fraction of a kilometer is equal to 37 centimeters. Does this all look familiar to you? You've seen it before? Maybe a long time ago? Okay, why don't you try number 21? Put your answer in the chat. It's 317.8 centimeters. Yeah, a lot of unit conversions in the sciences, like biology, as Wesley said there. A lot of answers coming in. They all look to be the same. Start and end. 1, 2, 3, 4. 4 places to the left. 1, 2, 3. Okay, very good. You seem to be picking this up. Or you knew it before, and it's looking familiar. All right, so we have this many HMs. Okay, so that's all length. You'll find that capacities like liters, that's the unit that we use for capacity. Liquid going into a container, think of that, capacity. Liters is the unit in the metric system. We have milliliters, we have kiloliters, and all the other ones as well. We don't use centiliters much, but we could, maybe in the sciences. We have grams, if you're going to do weight or mass. So we have grams, we have milligrams, aspirin, right? Drugs, milligrams, and kilograms, that's the heavy unit, and so on. So maybe we'll get to some of those other things later on. But. Okay, one of the hardest calculations in this unit is when you calculate area and volume. So let's talk about area. Area is a squared unit. And so when you're talking about finding areas, you need a base unit. So maybe this is your base unit. And then you ask yourself this question, how many of these little squares would cover this entire shape? And we have 1, 2, 3, 4 times 1, 2, 3, 4. There are 16 of those little squares. And so we would say that the measurement of this is 16 square units, whatever that unit would happen to be. If it was centimeters, then we would have 16 square centimeters. In one like this, what I like to do is just draw a rectangle of the same size and say this is 4 and this is 4. So the whole rectangle or square would have a area of 4 times 4 is 16, and then the shape that we were given is exactly, because of the diagonal here, this shape is exactly half of this square up here. If you just kind of draw this one here that has a area of 16, this represents exactly half of that. So the area equals 8 square units. We're going to get into more on area later in the course. All right, so square centimeters, square meters, or square kilometers. Determine the best unit of measurement to express the area of the object. The top of a desk, then certainly we would throw out square kilometers, it's too big. But, you know, maybe one of these other ones. I probably would do meters. And it would be a a small number, dollar bill, and we'll draw it. How many of these square centimeters? Certainly meters are too long, so this one probably square centimeters. National park, lots of area in a national park. Square kilometers, and the wall of a room, probably square meters. All right, so it's good to get a sense of the size of these things and know objects that correspond to them. But now we're looking at rectangular or square, little square units that cover an object. That's area. All right, and you see you have some up here as well that you can, just like before when we were looking at the area of a floor of a room. Well, we've got length times width in that room, and probably if you took a meter by meter big piece of tile and you laid them down, you'd probably have a room that's 25 square meters. Area of a television screen, just think about your favorite television screen. 2050 centimeters would be like 2 meters. So is your TV 2 meters wide? I guess some of them are. And if they do a 65-inch TV screen, they're giving you the diameter. So you could use that as a baseline. 2,000 centimeters, but remember, to get that number, it would be something like, 50 times 40 centimeters times centimeters. And that would give you 2,000 square centimeters. So probably we're looking at this one here. Millimeters would probably be too small. All right, you can look at the other ones. I would probably go with the area of the face of a small coin, like a dime. I don't know, I think millimeters is going to be too small. I might go with centimeters on that one. But I think centimeters is too large. So the area of a parcel of land in a large metropolitan area, which a house can be built. Well, let's say it's a rectangular lot, so maybe a 30 by 30. 30 times 30 is 900. 30 what? I don't know what this is. This is probably supposed to be I think probably that A is supposed to be an M, hectometer. Oops, hectometer squared probably. We're doing square units. Yeah, centimeters way too small, probably 900 meters, 30 meters by 30 meters. Okay, now the difficult problems here are because of the squared unit. And so I'll work through one just to kind of show you how it works out. And then, we'll ask you to try one. So let's do one like, number 47. How many feet are there in 1 yard? 3. So do you want to say 12 here? Many students do. And that would be an error. So here's how we're going to do this one, like number 47. 4 square yards, just think about something that's 2 yards wide by 2 yards, 2 yards by 2 yards would be equal to 4 square yards. 1, 2, 3, 4, 4 square yards, 2 by 2. So this is a unit. Just imagine each one of these is 1 yard by 1 yard. So here's what we're looking at. And we want to convert it to square feet. Now, if we wanted to convert it to square feet, then I'd have to divide each one of these yards here into 3 equal chunks. So it would look like this. And each one of these little squares in there, that would be 1 square foot. Now, how many of these little boxes do you see here? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 by 6, 36 square feet. So 4 square yards, if we just break each yard up into 3 feet, and we count the little of 1 by 1 feet, square feet boxes, we count them up, and you can see that there are 36 of them. So the answer we have to get here is 36. Let's do the unit analysis. When you have 4 yards, 4 square yards, we're going to write that as 4 yard times yard. Yard times yard is square yards. Then when we do the unit analysis, we have to cancel out 2 different yards. And when we're done, we want to have square feet. So we could write this as 3 feet equals 1 yard. Here's the unit fraction that we're using. And then we're going to do it again. 3 feet times 1 yard. We have to multiply by the 3 twice because we have to cancel out 2 yards instead of just 1. And then here you can see it. 4 times 3 times 3. 3 times 3 is 9. 9 times 4 is 36. We get 36. And then feet times feet is square feet. So you can see our little diagram gave us 36 square feet. And when we did unit analysis, we got 36 square feet as well. I will remind you when you make this error, because many students make it. So I put both the standard systems in here, the English standard system, and I also put some metric problems in here. So, okay. Now, the tricky part about this one is that we know we're moving 2 places to the left, but we have to do it twice because of the square unit. So you start with 10.9, and we're going to move the decimal point 2 places to the left, but we have to do that 1, 2 twice because of the squared unit. So there's one move of 2, and then we have to do another move of 2. So 0.00109 is the answer to this one. If you just move the decimal point 1 place, like you were doing with units of length, then you'd have an overestimate. The unit analysis part of this would be 10.9 DAM squared. That's 10.9 DAM times DAM, decameter times decameter. So we have to cancel out the decameters. And there are 100 decameters in 1 kilometer. But we have to do that twice so we can cancel out the 2 decameters. And then what we'd be left with is kilometers times kilometers. That's kilometers squared, square kilometers. But if you take 10.9 and divide by 100 and then divide by 100 again, you get 0.00109. I think the calculator will probably give it to you in scientific notation. No, give it to you in general form. All right, I'm going to skip the volume for now, and I'm going to fast track to the application problems. Okay, so this one says blue whales can weigh as much as 150 tons. 150 tons. Your car weighs about 2 tons, maybe a little less, depending upon the car. Convert the weight to pounds. So we need a conversion between tons and pounds. Does anybody know how many pounds are there in a ton? 1,000. Right, here it is on your formula sheet. 2,000 pounds is equal to 1 ton. The unit that we use for pounds is LB. Tons cancel. So you got to multiply these 2 numbers together, divide by 1. So what is that? 30. And then we've got 4 more zeros. 1, 2, 3, 4. 300,000 pounds. All right, they're also going to ask you to do a little bit of arithmetic in some application problems here. And so let's take a look at number 93. Fozzie's SUV is 6 feet 4 inches tall. And if he puts a 2 feet 10 inch box on top of his SUV, what's the total height of the SUV and the box? Okay, so here's the SUV, and from the bottom to the top, that height is feet 4 inches tall. And then they're going to put a box on top of the car, and the box is 2 feet 10 inches. All right, and then they want you to give the measurement of the whole height from the road up to the top of the box. So what we can do here is we can add the feet and then add the inches, and it would look something like this. So we've got the 6 foot 4 and the 2 feet 10. If you add the feet, you get 8 feet. If you add the inches, you get 14 inches. But if you're going to report something in feet and inches, you want the number of inches to be less than 12, because 12 inches is equal to 1 foot. So you're going to break down the 14 into 12 inches and 2 inches, because 12 inches is equal to 1 foot. And so you put the 1 foot with the 8 feet, and you get 9 feet, and then you've got 2 inches left over. So together, if you add 6 feet 4 inches and 2 feet 10 inches together, you're going to end up with 9 feet 2 inches. All right, one last application, tofu. 1 ounce of tofu provides 2 grams of protein. And so we think of this as like a unit fraction, because 1 ounce of tofu contains 2 grams of protein. When we put them over each other like this, we're going to get 1. because the amount of protein in each is the same. How many milligrams of protein are provided in 5 ounces of tofu? So we start off with the 5 ounces of tofu, and then we'll notice that in 1 ounce of tofu, there are 2 grams of protein. So we cancel the ounces of tofu, and what's left are 5 times 2, that's 10 grams of protein. However, if you read on, it says how many milligrams of protein are provided in 5 ounces of tofu. So we have to convert 10 grams to milligrams. All right, so it's the same old problem, only we're dealing in grams instead of feet here. And so we want to move from grams to milligrams. So begin and end. And we're going to go 1, 2, 3. 3 places to the right. So start with the decimal point, 10 grams, and we're going to move it 1, 2, 3 places to the right. We'll end there, and so we have 10,000. So this was a 2-step problem. You have to convert from tofu to protein, and then grams of protein, and then you got to convert from grams of protein to milligrams of protein, because that's how they asked the question.